Okay, so we went over all these questions in class today, but I wanted to work them out for you so you had an additional resource. Here, I'm going to go through pretty much all 23 of the review questions. So you can pause it, go back and forth as you need to, and see how to work them out. So I'm going to do the first two questions on this slide. So first we have number 1. It says, write in simplest exponential form, and I have the 4th root of x to the 2/3 power. Now, remember, this is in radical and exponential form. So first, I'm going to take everything that is inside, put it into parentheses, and then raise it to my new power. So 4 is the root, because roots grow underground, so they go on the bottom. That's why it goes on the bottom. And we're going to put 1 up top. Now, we are going to use the power rule, which tells me to multiply the two together. So I get x to the 2/3 times 1/4, which is x to the 2 times 1 is 2, 3 times 4 is 12, and I can simplify that by dividing each by 2. And I get x to the 1/6 power. And sorry if I keep sniffling. I just had a bag of hot Cheetos and they were a little bit too spicy for me. So now my nose is running. Hopefully it doesn't happen the entire time. Number 2 is the exact opposite. It says write in simplest radical form. And I start with 3 to the 6/9 power. Now 6 over 9 needs to be simplified first. I can divide each by 2, which gives me 2/3. So now I have 3 to the 2/3 power. And remember, on the last problem I said root grows underground, so that means 3 is my root. And that means that my base goes inside with my power up here. And that is number 2. For numbers 3 through 6, I am going to take a picture of each of those tables and I will work them out with you on the next slide. Okay, here are 3 and 4. I'll do 5 and 6 on the next slide. Number 3 says determine whether each expression is equivalent to x to the 5/3. Select yes or no. So the first thing I want to do is convert 5/3 into radical form because all of my answers are given to me in radical form. So remember, the root is 3 because it's on the bottom. It goes underneath. X to the 5th power. Now, if I look at the answer choices, that is actually an answer choice, so I'm going to select yes right away. I already know that that is one of the equivalent answers. Now, I also know that I can continue to simplify this problem because 3 goes into 5. So I can take out one group of x, and then I'm left with the cube root of 2 more inside, because remember, this is the same as expanding it as x times x times x times x times x. So I just took out this group of 3, and then these 2 stayed inside. Now that is also an answered choice. That is going to be the 5th row, or the second to last one. And that means I can't write this in any other way. I know that the first one is wrong, because if I convert it into exponential, I have x to the 3/5. So the root is 5. That's a no. This is the same as the square root of x, and I know that's x to the 1/2. That's also no. Right here, this one's pretty close, but remember, on this problem, my remainder was 2. This would be the equivalent to x to the 4/3, so that's no. And then finally, this is x to the 5/3, and I just put it underneath the square root, underneath the radical. That's completely wrong, because if I was converting that into exponential, I would have to solve this problem. So my only 2 answers are the 3rd and the 5th choice. For number 4, I also need to convert this into radical form. So since I have 2x cubed inside, I'm going to leave that in parentheses, or since it's in parentheses, I'm going to leave it. And now if I look right here at my root, I'm going to write that as the radical, or write that as the root in radical form. And then 2 up on top I'm just going to rewrite this here. Now, none of my answers quite look like that, so what I have to do is my power rule, which tells me multiply through. So there's a 1 right here, so I have the 5th root of 2 squared x to the 6th power. Okay, 2 squared is 4, and x to the 6th power stays. Now I can look, and that is actually an answer choice. So I am going to select that one. That's first a yes. Okay, but I want to check to see if there's anything else. Now I can continue to simplify this problem. 4, that only breaks down into 2 and 2. I can't simplify that part at all. Let me change the color. That's kind of bright and hard to see. 2 breaks down, I'll just go back to black. 4 breaks down into 2 and 2. I need a group of 5. That's no good, so 4 stays inside. Okay, inside my radical. But 5 does go into 6. It goes in 1 time, and there's 1 left over. If I expanded it, I would take a group of 5 and have 1 left over to give me 6. Now, x times the 5th root of 4x, that is also an answer choice, so we're going to check yes for that one. Now, the second one is not, because it's missing the x that was left inside. This might be 4x to the 5th power inside, which is incorrect, so that's a no. The third one, we forgot to distribute the square to the 2, so that's also a no. And on the last one, we forgot to distribute the square to the x, so that one is also a no. Number 5, determine whether each expression is equivalent. So this is x cubed equals 17. Remember, this is from our last lesson of this unit. X cubed, let me bring that down a little bit, equals 17. I want to turn this, so it doesn't matter if it's a radical or exponential, because I have, answer choices that have both. So what I'm going to do is put this over 1, because I need to find the reciprocal exponent. And that reciprocal exponent is 1/3. So I do that to both sides. So we get x equals 17 to the 1/3 power. That is an answer. I'm going to select yes. But there are a few radicals. So I'm going to convert this into radical form to see if I'm missing anything. So in order to do that, my root is 3. My base is 17, and my power is 1. But remember, we don't have to write that. So if I just have the cube root of 17, that is also an answer choice. Now, the other ones are no. The first one is no because it's 17 cubed. That's like if I just applied a cube to both sides, which I didn't do. Instead, I had to apply the 1/3, so this is a no. And then the last one is also incorrect because it's in a fraction. That would have been 17 to the negative 1/3 power, and that's not what I had. It was a positive, so this one is also no. Number 6 says determine whether each expression is equivalent to 5 to the negative 1/2, and that actually ties back into what I just said on the last one. 5 to the negative 1/2. This negative tells me put it under 1 or give it a fraction, and I have 5 to the 1/2. Now, let's look. Is that an answer? Yep. That's the last one. 5 squared is not the same, and I can look because 5 squared and 5 to the negative 1/2 have the same base, but their exponents don't match, so that's a no. The second one would be correct if I had 5 to the negative 2, which I don't. I have 5 to the negative 1/2, so that's also a no. Number 6 is, this is number 6. The third one is completely wrong because this negative isn't useful to me at all. This negative is what the mistake that you all make from my negative exponent, but remember, negative exponents turn into fractions, not into negative numbers, and then the exponent is completely wrong because it's missing that fraction as well. So the only answer on number 6 is the last one. Number 7 says simplify and write in exponential form. So I have the 4th root, my stylus is still being weird, of 4 squared times the 4th root of 4 cubed. Now, I can combine what's inside the radicals first since I have the same root, but what I've noticed from you all is that you prefer to turn it into exponential form first, which is totally okay, so I'm going to do the same just for, length's sake to make this video a little bit shorter. I have 4 to the 2 over 4 because 4 is my root. and then times 4 to the 3 over 4. Now, you guys are pretty good at recognizing when something needs to be simplified. 2 over 4, I know that you all would say it needs to be simplified, but you're also good at noticing that you have to add, and I do have a common denominator, so I don't want to simplify at this point. Instead, I'm going to use my product rule, add the exponents, and I get 4 to the 5/4 power as this final answer. Number 8 is asking me to do the same thing, write an exponential form. I have the 4th root of 2x squared times the 4th root of 2x cubed. So 2x squared is in parentheses because it's inside. I'm going to raise that to the 1/4 power times 2x cubed in parentheses again to the 1/4 power. Power rule tells me to distribute that exponent through. So I have 2 to the 1/4 times x to the 2 over 4 times 2 to the 1/4 times x to the 3 over 4. Now, I have a same base and another same base. So I'm going to rearrange this according to bases. So I have 2 to the 1/4 times 2 to the 1/4, because I had 2 of the same thing, times x to the 2/4 times x to the 3/4. Now, since I'm multiplying, we are going to use the product rule, which tells us to add. So I have 2 to the 1/4 plus 1/4 times x to the 2/4 plus 3/4, which is 2 to the 2/4, x to the 5/4, and finally in this step is where you would simplify. So I have 2 to the 1/2 x to the 5/4 as this final answer. And remember, be careful, because this was the one I made a mistake on during class because I didn't read the directions. I put it in radical form and it clearly says exponential, so be careful and write this using the correct form. Number 9 is a little bit different because it's asking me to do something else. And the last two said write in exponential form, but this one says write in radical form. So number 9 says 16 to the 1/4 times 16 to the 2/3. So when I'm multiplying, I add the exponents, same base. So I have 16 to the 1/4 plus 2/3. 1/4 plus 2/3 does not have a common denominator, but my common denominator is going to be 12. So I will need to multiply each fraction by a number that gives me that number. So I'm going to multiply by 3 on the left side and by 4 on the right side. So 3 times 1 is 3. 2 times 4 is 8. So I have 8 plus 3 is 11/12. Now, this is my exponent, so I have to remember to put it back on my base of 16. And if you left it there, this is where we have some issues because we read the directions. It says radical form. So I have root, or radical, my root is 12. I have 16 to the 11th power. Okay, that can't be simplified. However, I can change 16, okay? Because I can write 16. I'm going to highlight this in green and then write it in green. I can write 16 as 4 squared and the 12th root, and 11 stay the same, which means I have the 12th root of 4 to the 22nd power. Now, 12 does go into 22. It goes in one time, so I can take out a 4. Actually, that's not even the smallest I can go. Let's try this again. Instead of 4, let's do another one. I'm going to highlight the 4 in pink because that can be written as 2. So now I have 2 squared inside. And then the 12th root of 11, nope, not 11, 22. So the 12th root of 2 to the 44th power, and 12 can go into 44. It actually goes in 3 times. So now I have 2 cubed equals, not equals, I need to eat a snack. 2 cubed times the 12th root of, okay, now 3 times 12 is 36, so now I need 8 more, so I'm left with 2 to the 8th. Okay, is this fully simplified? Yes. However, on a problem like this, if I'm not giving you a calculator, I will totally accept this answer, and I think that's the one I gave you during class. But if you wanted to continue, the final answer would be 8 times the 12th root of 2 to the 8th. But if you leave 12th root of 16 to the 11th, that is more than good enough for me. Number 10 is also in radical form. I have 1/3 x to the 1/4 times 1/3 x to the 2/3. Now this one, I got a question on in every single class, I think. And this is a good question. Remember, these 1/3, they don't have the exponent. Only x has the exponent. So I can rewrite 1/3 times 1/3, because those are coefficients, times x to the 1/4 times x to the 2/3. Okay, now 1/3 times 1/3 is 1/9. 1 times 1 is 1. 3 times 3 is 9. And then my product rule applies for my exponents. 1/4 plus 2/3. This doesn't have a common denominator, so I will have to find one, and rather than do that again, it's going to be the same as the previous question. So I'm just going to skip a couple steps and say I have 1/9 x to the 11 over 12, because I would do all of this work again, since it's the same exponent. Now, x is still the only thing with an exponent, so 1/9 goes outside, and I have the 12th root of x to the 11th, and this is my final answer for number 10. Number 11 says solve the following equation for x. I have the 4th root of 64 to the 1/3 equals 64 to the 1 over x. Okay. My right side is an exponential form, so I'm going to convert the left side into it as well. 1/3 times 1/4 is 1/12. Excuse me, my bases are the same, so I can set the exponents equal to each other. So x equals 12. Number 12 is the same idea, but I have the cube root of 27 squared times the cube root of 27 to the 5th equals 27 to the x over 3. So I have 27 to the 2/3 times 27 to the 5/3 equals 27 to the x/3. Adding my exponents, because of the product rule, gives me 2/3 plus 5/3. So I have 27 to the 7/3 equals 27 to the x/3. Since my bases are the same, I can set the fractions equal. So x equals 7. Number 13 is next. So this one is the same idea, but it is, oh no, it's pretty much the same. The 5th root of 3 to the 7th, I was thinking about 14, equals 3 to the 4/5 times 3 to the 3 over x. So I'm going to turn this into exponential form so that I get 7/5. And I also know that I can add the exponents on the right side since I'm using the product rule. So I have 3 to the 7/5 equals 3 to the 4/5 plus 3 over x. Now this one's a little bit different because x is in my denominator, okay? But the bases are the same, so I'm going to rewrite this problem. And I do see that 3 plus 4 is indeed 7. In order for me to be able to add fractions like that, their denominators have to be the same. So I have a denominator of 5 and 5, so x must also be 5 in order for that to work. Now, if you don't like to do it that way, I'm going to show you the other way on number 14, which is going to work just as good. In that case, you would subtract one of the fractions over. So on 14, I have 16 to the 5/4 divided by 16 to the 1 over x equals the cube root of 16 cubed. So I'm going to do two steps at once. I'm going to subtract my exponents because of the quotient rule, and I'm also going to turn this into exponential form at the same time. Since bases are the same, I can set the exponents equal, and I look at this, and I can't even do the same thing I did on number 14 in the same way, because 5 minus 1 is 4, not 3, and I already have some mismatched denominators. So instead, I'm going to subtract 5/4 from both sides. Subtract 5/4. And now I'm left with negative 1 over x equals 3/3 minus 5/4. Well, on the right side, I have different denominators, so I can't subtract them until I find a common denominator. So I have negative 1 over x equals 4 times 3 is 12 over 12 minus 15 over 12. So I have negative 1x, negative 1 over x equals negative 3 over 12. Well, these still don't match, but I see that negative 3 over 12 can be simplified. I can divide by 3. So I get negative 1 over x equals negative 1 over 4. So that means x equals 4. Next question is number 15. I have solved the following equation for x, and most of you like to convert 25. So I have x cubed equals 5 squared, because 25 is 5 squared. My reciprocal exponent is going to be 1/3. So that means I get x equals 5 to the 2/3. For number 16, I get x, same directions, x to the 4th equals 1 over 49. Now, you guys like to do this one too. So the square root of 49 is 7, so I know it'll be a 7 squared, but since it's a fraction, that means I have to the negative 2. So x to the 4th equals 7 to the negative 2. My reciprocal fraction is 1/4. So x equals 7 to the negative 2 over 4, which is simplified to negative 1 over 2 for the final answer on number 16. Number 17 is another same type of question. Solve for x. I have x to the 5th equals the cube root of 4. Again, I can simplify 4 to be 2 squared. And this is in radical form, so I'm actually going to write that into exponential form. So I get x to the 5th equals 2 to the power of 2 divided by the root of 3. Now I can apply my reciprocal exponent. And I get x equals base of 2 still. 2 times 1 is 2, and 3 times 5 is 15. Now in class, I think I wrote this as 4 to the 1 over 15. That's an equivalent form. Those mean the same thing. Number 18 says rewrite the following in exponential form. So I have the fourth root of 100x to the 6th power. Before I keep going, I want to simplify 100 in the same way to be 10 squared x to the 6th power. And then since this whole thing is inside, I'm going to put it inside some parentheses. Now for my exponent, my root is 4 and the power is 1. We can distribute this to each of the exponents using our power rule. So I have 10 to the 2 over 4, x to the 6 over 4. And this equals 10 to the 1 over 2, x to the 3 over 2. And I think in class I also made a mistake on this one. I wrote it in radical form still. And I think the answer I gave quite a few of you was 100 to the 1 over 4 instead of 10 to the 1/2. Those are equivalent, so I would accept either one of these answers. Number 19 says simplify completely. And I have, whoops, that's an S, not a 3, to the -4. Negative exponent tells me fraction, and then 3 to the 4th power is 81. That would be a final answer. Number 20 says write x to the 24th in the form x to the n all to the m. So remember, this is just applying our power rule, and n and m can be anything as long as they're both factors of 24. So I can have x to the 1 to the 24th, or the reverse. I can have x to the 2 to the 12th, or the reverse. I can have x to the 3 to the 8th, or the reverse. And I can have x to the 4 to the 6th, or the reverse. And finally, I have my last three. Number 21 says write an equivalent expression to 3r squared s to the 4th r, all raised to the 2nd power. So pretty much I just need to simplify this by using my rule. So I have 4 things inside the parentheses. I have 3 squared, r squared times 2 is r to the 4th, sorry, s to the 8th, and then an r squared still. 3 squared can be simplified to be 9, and these, I wrote it wrong, dang it. This is r to the 2nd power, and then these two r's can be combined to be r to the 6th, s to the 8th for this final answer. Now, if you noticed in the first step, I have r squared and an r, and made that r cubed, you would still get the same answer. But a lot of you, I noticed, like to simplify at the end. You like to do the power rule first. Number 22 says write an equivalent expression to 1/4 x squared y times negative 8y cubed. So I have 1/4 x squared y times negative 8y cubed. Like terms are 1/4 and negative 8. They're both coefficient terms. X squared, there's no other x term. And then y and y cubed go together. So I have 1/4 times negative 8 times x squared times y cubed. 1/4 times negative 8 is negative 8 over 4, which is negative 2 x squared. And then my y's that combine give me y to the 4th. And last one is number 23, the cube root of 54 x cubed y to the 5th z, and the directions say simplified completely. Write your answer in simplified radical form. So the first thing I want to do is I can break 54 down into 9 and 6, which can be broken down into 3 and 3, and 3 and 2. And if you remember, I need groups of 3. So here's one group of 3, and then 2 is a loner. Okay, so 3 comes outside of the radical, and then 2 goes inside, so this is that 3. Now, my next piece is x to the 3rd power, so I have 3 full groups there. Does anything stay inside? No, because 3 goes into 3 one time with no remainder. Next is my y to the 5th power. And 3 goes into y 1 time. And then there's a remainder of 2. And then there are not enough z's to come out, so they stay inside. So my final answer is 3xy times the cube root of 2y squared z. Okay, so study this, go through the questions, and you should be good to go for tomorrow's test.